Hi to all. In this quick video, we will just cover the valuation of a stock using the dividend discount model and assuming that this is a company that has already reached a stable level of growth. So we can assume at least that the company will grow at this percentage rate, at this growth rate forever, okay, for the foreseeable future. So let's first start with a long approach and then I will quickly summarize this approach and we will just use the formula which will make our lives much easier. So what is the price? The price of any security is just equal to the sum of the present value uh, of or of the future cash flows. And I have to add a very important word here, which is expected, because whatever happens in the future, we can only expect. We can have an expectation about what will happen in the future, but there is still not certainty about these future cash flows. Right now, when you read this problem, the first thing you see is that this company just paid a dividend. So that dividend, which was just paid of $2, that is in the past, that is already reflected in the stock price. So we do not do anything. We are not interested in this $2 dividend because it already happened. Okay, so now what we are interested in are the next dividends, the future dividends. Now we get the information and we get a couple of things such as D0, right? That we are not interested in it, but let's just write it here. And then the growth, stable growth, or I'll just use long-term growth, LTG, and then it will be 2%. And then the R, which is the required rate of return, and that required rate of return in a dividend discount model. So we're talking about equity holders. So we usually this R is calculated using the capital asset pricing model. But now we are given this rate, which is a 5%, right? So we have these um, variables. These are the variables we are given. Now, if we know the dividend was $2 and we know that the long-term growth rate is 2%, we can calculate how what the next dividends will be. So for instance, the dividend one will be simply these $2, and then we will just multiply this by 1 plus this 2%, right? By 1.02. So we are just saying dividend, this is the same as saying $2 plus 2% times $2. So $2 plus 2% of $2. And then we end up $2 times 1.02. So we are having the dividends growing at a 2% rate. Okay, now we will do the same for the foreseeable future. So now we know 2.04 and I will write it here. This is D1. So D1 is $2 once again times 1 plus this 2%. So we know this. Now we can do the same for the following dividends. This one is 2.04 times 1 plus this 2%, which is the long-term rate, growth rate. This is the growth rate that we expect to remain constant for the foreseeable future, right? And if we lock this rate here, then we can scroll this down and we can scroll time down. I'll first scroll time down and I will get this. Let's assume this is yearly data. So let's go 423, 418 years into the future. Now let's just scroll down these dividends as well. And if you're not familiar with this, if you place your cursor here in the bottom of the cell, in the rightmost part of a cell, then your cursor will turn to this black cross. When that happens, you can just double click, and if you already have a series of data here in this column, it will just update the formula, whatever formula you had before, it will update it and it will scroll down until the last value of the series of data you have in the column which is right beside it, right? And those dividends seem a little large. So yeah, and then these dividends are growing by this 2%, and that is yeah, this is okay. Now, if we get the present value of these dividends, then how do we get the present value of these dividends? We just divide each one of these dividends by 1 plus this rate, and we have to lock this rate because we want to keep using this rate when we scroll down to the power of time. We do not lock the time because we want the cell reference to change as we scroll down for the time variable. Okay, and now we just scroll this down. Now, when we look at this, we can do something up here rather than moving down and doing this at the bottom of a column. We can right here say, well, I want to sum all of these. Let's do it here. I want to sum, let's do it here, sum of future cash flows. And then this is cool. We just do sum CC. So it will sum every single value we have in that column. Okay, once again, sum CC. We could have also just say, well, C7 to C420 something, right? But rather than that, I can just add the whole column because the only values we have here are the present values. Okay, so now if we follow this, um, according to this definition, this is the price of the stock. Let me remove a couple of decimals and add the dollar symbol so now it looks more like a price. Now, what is a shorter way using the dividend discount model? A one-step dividend discount model. The firm has already reached this stable, this stage in the life cycle where it is growing at a stable rate for the foreseeable future. So we can use this formula, which is, well, D1. So price is also the same as D1. That's the first dividend occurring in the future divided by R minus G. So this is just a shortcut to what we have done, a mathematical shortcut to what we have done. And let's prove that it actually works. So the price will be equal to D1, we have D1 here, divided by R, we have our discount rate here, minus the long-term or stable growth rate, we have it here. And if we do this, we will also reach the same. So it is just a shortcut and we are reaching the same price that we did using the long approach. Okay, so for the purposes of this question, you do not need to do all of this lengthy process. You just need this dividend discount model formula, and therefore you can easily, using this formula D1 divided by R minus G, you can easily get this price, which is 68, and that is the current value of the stock. And this is saying after paying the dividend, yeah, of course, because it just paid the dividend of $2 per share. So this is a price after paying the dividend. Okay, so thank you very much for your attention. I hope this is helpful.